Welcome back Year 9 to the next video tutorial for our indices topic. What we're going to do today is look at fractional indices. So what does this mean? Have a look at this here, a to the power of a half. So what we've looked at so far are indices where we've got a positive integer, a positive whole number. We've also looked at negative indices, and that's where we had a negative whole number. In this part of our topic, we're going to look at what happens when we have a fraction as our index. We're going to have a look at some special cases. Now, to start off with, let's look at this case here that I want you to consider. If we had a number to the power of a half multiplied by itself, so multiplied by another number to the power of half, that same base a, let's first work at using just our normal index laws that we've studied already. Let's add the indices and see what result we get. So this would be a to the half plus a half. Of course, if we're multiplying here, the same base, we add the indices. 1/2 plus 1/2 is 1, isn't it? 1 whole. Well, we can just write a. We don't need to write this index of 1. So as you can see, we've got a to the power of half multiplied by a to the power of a half is actually equal to a over here. So if I look at this in more detail, this means a number multiplied by itself gives me a. Can you think of, what do we call this number? What do we call this here? We're looking for something that's multiplied by itself to give me a. You might like to think about what this symbol here means. This is a square root, isn't it? And what the square root does is tell me, if I'm given a number a, what number will multiply by itself to give me that answer, to give me that product of a. Let me use some numbers in this just to make it a little bit more clear. Just say I gave you the number 9 and I said to you, what number multiplies by itself to give you 9? And you would say to me, oh, well, that's 3. 3 times 3 is 9, isn't it? What you're essentially giving me when you tell me the number 3, you're giving me the square root of 9. You're telling me if I take the square root of 9, I will get that number that will multiply by itself to give me 9. So I could rewrite that number sentence there, that equation, like this. The square root of 9 multiplied by the square root of 9 is equal to 9, or 3 3s are 9. So have a look. I've actually written that there using numbers, haven't I? Now, what I'm getting at is that this here, a to the power of half multiplied by a to the half, is equal to a. But the square root of a is also equal to a when you multiply. So what we can say is that this here, a number to the power of a half, is actually equal to the square root of that number, which is really, really handy. I'm going to write that at the bottom here. A to the power of a half is equal to the square root of a. So these are just two different ways of writing the same thing. Whenever you see this to the power of half, I want you to automatically think, okay, that means the square root of that number. This is going to allow us to evaluate these fractional indices. Okay, I want to show you another case. If we take this a little bit further, what if we had a to the power of a third? If I take this a to the power of a third and I multiply it by itself 3 times, so therefore taking it to the power of 3, I've rewritten that here long ways. That means a to the power of a third multiplied by a to the power of a third by a to the power of a third. It's a bit of a mouthful, isn't it? Alright, so we can actually do the same thing here. Let me get the answer to this if I simplify. This would be a to a third plus a third plus a third, 3/3, which is 1. So that's equal to a. A to the power of 1, of course. That's what I've done there. So essentially what we've done here as well is said, okay, what number multiplies by itself, but then by itself again to give me A? We do have a symbol for this. It's not the square root. It actually looks like this. It's the same square root symbol. Okay, it's the root symbol, but instead of a square root, it's called a cube root, and we put a little 3 there to represent that cube. So I'm going to rewrite this similarly to what I did with the square roots in the previous slide, but it's actually cube roots now. So if I've got a number A, there will be a particular number that can multiply by itself and itself again. So this is to the power of 3, isn't it? So there is a number that if I take it to the power of 3, I will get A. And we use this symbol here, the cube root, to find that number or to represent that number. Now I've just summarized that at the bottom. This is called the cube root, and there's the symbol there. Now, like with any video, please pause it wherever you wish if you'd like to jot down these notes. So, what does this mean? Well, this means that the cube root of A is actually equal to A to the power of 1 over 3. So exactly what I did before. Just use a different colour to highlight this. But this symbol here, A to the power of 3, 1/3 I should say, 1 over 3, is equal to this here, the cube root of A, equals. Now what I'll do is I'll bring up another slide here where I've actually summarised these rules. There they are. A to the half is equal to the square root of A. A to the third is equal to the cube root of A. Now before I go on, I did want to just look at some cube roots just to make it a little bit more clear, hopefully. When we do square roots, I might say to you, okay, what's the square root of 9? And you can tell me that's 3. So that's nice and simple. With cube roots, I'm looking for that number that will multiply by itself again. So let's look at this. Cube root of 8. So I'm looking for a number that will multiply by itself and then itself again, and the answer will be 8. So automatically you can probably say, well, if I took the number 3 and multiplied by itself just the one time, I'm going to get 9, which is above 8 already. So I need to choose a lower number. I'm going to choose 2. Let's have a look. 2 times 2 times 2, what's that equal to? 2 2s are 4, 4 2s are 8, aren't they? So this is good. This is what I want. I'm just going to get rid of that because our actual answer to the cube root of 8 is simply 2. I'll just put in brackets here because 2 to the power of 3 equals 8. So you can see we're working in reverse. If 2 to the power of 3 equals 8, therefore the cube root of 8 must equal 2. Let's do this next one. The cube root of 27. Alright, well I know that it can't be 2 because the 2 cubed is 8. So how about we try 3? I might do it on the side here. 3 3s are 9. If we multiply by 3 again, what do we get? 9 3s are 27. Good. So the cube root of 27 is 3. Now I'll follow this, do the same, because 3 times 3 times 3, or 3 cubed, is equal to 27. Again, we're working backwards. Given 27, what number can I take to the power of 3 that will give me that? Try the next one, 64. So this is getting a lot higher now. Well, we know it's not 2 or 3. Let's try 4. 4 times 4 is 16. 16 times 4 is 64. You can see I'm going with a little bit of a pattern here. like 6, does it? There we go. So the cube root of 64 is 4 because 4 cubed is 64. Try the next one before I do it. You might have guessed it, yes? The cube root of 125 is 5 because 5 cubed is 125. 5 times 5 times 5. The last one, this is an easy one, isn't it? Hopefully you can see what it might be. The cube root of 1000 is 10, and that's because 10 times 10 times 10 is 1000. So that's just a little bit extra on cube roots. If they hopefully weren't too confused when I went through that before. We'll go back to this slide here, the general rules. So we know that a to the power of a half is the square root of a. A to the power of 1/3 is the cube root of a. I can actually take this further. Now this is probably a little bit beyond our Year 9 course, but it's good to know anyway because it is a general rule. Therefore, if you have a fractional index where it's got a to the 1/4 or perhaps a to the power of 1/5, etc., we can actually convert it to a root. So it may not be a square root or a cube root. It will be whatever number you've got here as your denominator. So this is a denominator of 4, so it's the 4th root. Denominator of 5 will equate to a 5th root. So this means what number will multiply by itself, itself again, and itself again. So what number to the power of 4 will give me this one here? Now we can write that in a general form. Instead of using a number here, we can use a letter. So in that denominator position, I've put an n, and that will represent the nth root. We say nth. So that's for any number we can go to with this. It's a mathematical rule that will work every time. We'll focus mostly though on these to the power of a half and to a power of a third. Okay, let's look at some examples. How will we actually work around this? How will we use it in our maths? Let's look at this first one, evaluate. So that means find the answer. What is the actual numerical answer to this sum here? 25 to the power of a half. So we can convert that straight away. If you see that to the power of a half, it means the square root. The square root of 25 is 5. Try the next one. 16 to the power of a half, again, that means the square root of 16, and that's 4. The next one, again, we've got to the power of a half. We know that that means the square root, and the square root of 49, what number multiplies by itself to give you 49? Remember I said knowing your times tables is really, really essential here, so you should be practicing them if you think that you might be a bit rusty. Okay, this one's a little different. Notice here, it's not a half anymore, it's 1/3. So this means the cube root. So what number to the power of 3 will give me 27? We did this one before, didn't we? 3 to the power of 3, I'll just put that in brackets, is equal to 27. So the cube root of 27 is 3. Again, I've got 1/3 here, don't I? 125 to the power of a third. So this is the cube root of 125. What number cubed, or what number to the power of 3 gives me 125? The number 5. So just in brackets, I'm just doing this to show you how you get your answer. You don't need to put this bit here in brackets. Okay? This last one, I put it in because it's a little trickier. 32 to the power of 1/5. Now, if you can remember our general rule before, you can remember that if you've got this denominator of 5, that means that our root, that tells you what root we go to. So it must be the fifth root of 32. So this is saying what number to the power of 5 gives me 32? What number to the power of 5 will give me 32? Now, have a think about it. Well, it can't be a number 1 because 1 times 1 times 1 is always going to be 1, isn't it? It can't really be 3 because we know that 3 cubed is 27. And if you multiply that by itself by 3 again, if you multiply it by 3, that's going to be well above 32. So already I'm thinking I need to test out this number. 2 times 2 is 4, 4 2s are 8, 8 2s are 16, 16 2s are 32. So 2 to the power of 5 is 32, therefore the fifth root of 32 is the number 2. So that's a much trickier one, that one at the bottom. And you can imagine that once you get sort of really big numbers, it would be harder to do that in your head. But these little ones here, 2 to the power of 5, things like 5 to the power of 3, we should be familiar with what these are equal to. These square roots here, these cube roots as well. We need to have these in our head. We need to know them. It's good practice, and especially if you're going into, say, methods next year or beyond. These are some number facts that you've got to be good at them. Okay. Just a few more examples, just some simplifying using these fractional indices. Now, don't forget your index laws, okay? They're going to keep coming up. What have we got here? X to the power of a half, and that there is being raised to a power of 2. So what do? We multiply the indices. So this is x to the power of a half times 2, which of course is x to the power of 1, but I'm not going to write that one there. This next one, y to the power of a third, but that 1/3 must be multiplied by 3. That gives me 3/3, which is 1 as well. So that's my answer there. Remember, we don't write that one. It's just assumed that it's there. When there's no index shown, we know it's a 1. This one here, I might do this in 2 steps. This is 1/3 times 6. So that's the same as 6 over 3. 6/3. 1/3 times 6 is 6/3. 6/3, or 6 over 3, is 2. So that's actually equal to c squared when you simplify it. And this last one, z to the power of 10, but that is being raised to the power of 1 over 5. So what we'll do is we'll multiply the indices again. So this is 10, 1 over 5, 10 times 1 over 5, 10 fifths. 10 over 5, 10 over 5 is 2. So that's also equal to z squared. So all I had to do here was multiply out the indices, multiply that fraction by the power, or by this power here by that fraction. So whilst they don't look great when you first come across them, you might be a little alarmed when you see these fractions here. We follow the same index laws that we've been using this whole topic. Last lot of examples for you. Here we go. These ones are a little bit more challenging, okay, but have a go. Now, a to the power of 2 over 3. Now, all the fractional indices we've been looking at already, they've had a 1 on as the numerator, haven't they? But this doesn't matter. What we can do a little trick. If I write this as a to the power of 1 over 3, what index could I put here so that I could get that 2 over 3? What would I multiply by 1/3 to get 2 over 3? Multiply by 2, wouldn't I? So this here is now the same as that, because if I was to multiply these out, I would get 2/3. So what do you think I might be able to do now? If this is 1 over 3, that's the cube root, isn't it? It's actually the cube root of 8, and that is being squared. What multiplies by itself and itself again? So what to the power of 3 would give me 8? Might have guessed it. It's 2. So this is actually 2 squared. Now you can leave it in the bracket if you want, but it's not going to make a difference. 2 squared is 4. So that's the first one. This next one here, I'm going to do a similar thing. I'm going to do a similar little trick. First, I'm going to write this as 4 to the power of a half, because you can see this is 3 over 2, or 3 halves. So what could I put here? If I was to multiply this number, this index here, by the half, how would I get it to be 3 over 2? I'd need to multiply those numerators together, wouldn't I? 3 times 1 over 2. So it's a nice little trick, because now what we have is 4 to the power of a half, which we know is, yes, you guessed it, hopefully the square root of 4, and that is being raised to the power of 3. Square root of 4 is 2, so it's 2 to the power of 3. 2 to the power of 3 is 8. This last one here is a bit of a nastier one, because look, we've got a negative index. So what I'm going to do first is change this so it's a positive index. Hopefully you can remember that from your negative indices. Oh, I have made a mistake. Maybe you noticed it before I did. 1 over 25, and it's a positive index now because we've moved it to the bottom, haven't we? So we know that when we use negative indices that you can move those terms from top to bottom or from bottom to top, but the sign must change. So this is equal to 1 over the square root of 25, because that is to the power of a half, and we know that to the power of a half is equal to, saying the square root, 1 over 5 is my answer. So, like I said, pause wherever you need to if you'd like to get these as examples in, say, your summary notes. Thank you very much for listening. Sorry, this was a bit of a long video in the end, but it's something that does require lots of practice. Thanks very much, and we'll see you in class.